Okay, so I reread this just now, and I don't know if maybe it's clear, but it wasn't actually clear to me after I reread it. Um, Something like that. So which functional group is that? Alkene? hmm That? Alkyne? I mean, if you would have, this is totally fine too. So there's the first molecule, same thing. Um, so we have an alkene, we have an alkyne. Let's do an alcohol group. We could do an ether. That's an ester. Yeah. How about that one? hmm Or amine? Oh no, no. It's an amine. The yeah. There's the amide. So the amide needs to have a doubly bonded oxygen on the carbon that the nitrogen is attached to, and the other nitrogen group can't. Let's see. We could do 2, 3, 4. Or we could do something like CH3, CH2, CH2, COOH. Those would be the same thing. So that's a carboxylic acid. And then we would need something like a and so what's this one here? No, that's that one. The ketone is this one over here. Doubly bonded oxygen on a carbon with carbons on both sides is the ketone, and carbon on one side is the aldehyde. Am I missing anything? Let's take a peek. Heterocyclic ring structural and a phenol. I think I'm past it. All right, whatever. Guess not. So we could do 1, 2, 3. This is 4-carbon chain with a phenyl group, a phenyl group on it, and then a heterocyclic ring structure. So 2, 3, 4, something like that. So carbon, 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 and then a nitrogen stuck in that ring structure. Let's see. Oh yeah, 2, 3, 4. Alkyl halide. I think that's it. All right, so how about naming this one? Really close. You don't need it, right? Because whichever carbon it's on, it's going to be carbon down. If there's something else there, then you'll write a 1. But if there's nothing else there, you just don't even need it. So like, how about the next one? Nice. Yeah, I know it's stupid, the double I, but there isn't really anything you can do about it because it's iauto and you need the di again, the die itself is stupid. But yeah. And this next one, almost the same thing, right?
1, 2, dichloro, cyclopropane.
Okay. So we got a hexane, right? And it doesn't really matter what side we count from, so I'll just go 1, 2, 3, 4. So then we're at 3, 4 di methyl hexane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it doesn't matter on this next one. So we've got a pentane. So when I say pentane, I've taken care of those 4. And then 1, 2, and 3. So on number 3, I have an ethyl. And also on number 3, I have a methyl. Yep. All right, so we're going to draw this table. So I've got an ethane, so that's 2 carbons. And there's a chlorine on number 1 and a chlorine on number 2. So that would be the whole molecule. And then a hexane, so 2, 3, 4, 5, 6. And then in carbon number 2, there's a methyl group, and carbon number 3, there's a methyl group. And then there's a propane with a methyl group on the middle carbon. And then there's a butane, 2, 3, 4. And then on carbon number 2, there's a bromine. You guys okay with me putting that bromine in that spot and calling it number 2? Doesn't matter what side I count from. Oh, that's it.